One of the things that you learned when you were in grade 7 is that there are 4 major types of compounds: acids, bases, salts, and neutral. Neutral is actually exemplified by water. However, in reality, there are only 3 major types of compounds: acids, bases, and neutral. Salts can further be classified into acid, base, or neutral. Now, before going to classification of salts, let's have here some concepts that can help us classifying salt as either acid, base, or neutral. For the first concept, the anions of strong acids are weak bases, and the cations of strong bases are weak acids. Now, just a review, these are the anions of strong acids. These are the anions that can make the strong acid, and these are the cations that can make strong bases. Now, individually, when these anions are not combined to positively charged hydrogen, they are considered bases, specifically weak bases. On the other hand, these cations here, individually, when they are not combined to hydroxide ion, they are considered acids or acidic. Specifically, they are weak acids. For the second concept, water is much stronger base than the anions of strong acids and much stronger acid than the cations of strong bases. Now take note that in Bronsted-Lowry acid-base definition, water can act both as an acid and as a base. As a base, it is actually much stronger than the anions of strong acids and much stronger acid than the cations of strong bases. These two here, the anions of strong acids and the cations of strong bases, are much weaker than the water molecule. For the third concept, ions can only react with water if they are stronger acids or bases than water. And with this third concept, then therefore, anions of strong acids and cations of strong bases cannot react with water molecule, because again, anions of strong acids and cations of strong bases are much weaker than water molecule. So, which ions are considered stronger acids or bases than water? Those are the anions that are not enlisted here or here. Okay? Any type of anion that are actually not enlisted here, or any type of cations that are not enlisted here, are considered stronger acids or bases than water. And they are the only ones that can react with water molecule. And for the fourth one, water can dissociate into positively charged hydrogen and negatively charged hydroxide ion. Now take note that this dissociation will only happen if water molecule reacted to other ions or to other molecules existing in a solution. Now let's proceed to the classification of salt. According to Arrhenius' definition, salt is one of the products in Arrhenius acid-base reaction. Salt is a type of ionic compound that neither gives off hydrogen ion nor hydroxide ion. And of course, as an ionic compound, it consists of a cation and an ion. Now, there are 3 types of salts: the neutral salt, acidic salt, and alkaline salt. For the neutral salt is a type of salt that is made of cation of strong base and anion of strong acid. These neutral salts create neutral solution once they are dissolved in water. Example of these salts include sodium chloride, barium sulfate, and strontium nitrate. Okay? As we have noticed here in these examples, sodium chloride is made of cation of strong base. Remember that sodium is one of the cation of strong base. So just a review, these are our cations of strong base, and sodium is one of the cation of strong base. Okay? And anion of strong acid. Chlorine is actually an anion of strong acid. Chloride ion is actually an anion of strong acid. So sodium chloride is a neutral salt. Another one is barium sulfate. Barium is a cation of strong base. And sulfate, SO4, is an anion of strong acid. Now take note that these neutral salts are considered neutral because nothing will happen when they are dissolved in water. Nothing will happen on water molecule. Water molecule will neither give off hydrogen ion nor hydroxide ion. Why? Again, according to our third concept earlier, ions can only react with water if they are stronger acids or bases than water. Okay. Now, the anions of strong acids, one of the component of neutral salt, and the cations of strong bases, one of the component of neutral salts, are much weaker than water molecule, and therefore these two cannot react with water molecule to form either hydrogen ion or hydroxide ion. Therefore, nothing will happen on water molecule. Water molecule will remain as it is, and therefore it will produce a neutral solution. Okay. For the second type of salt, we have here the acidic salt. Acidic salt is made of the cation of weak base and anion of strong acid. Some examples of acidic salt include silver nitrate and magnesium sulfate. Now, as we have noticed here, silver nitrate is made of cation of a weak base. Okay, so these are the cations of strong bases, and as we have noticed here, there is no silver here, there is no Ag here. Therefore, silver is considered a cation of a weak base, not strong base. Okay, and nitrate NO3 is actually an anion of strong acid. We have here the NO3 as the anion of strong acid. So, therefore, silver nitrate is considered an acidic solution, acidic salt. Magnesium sulfate is also an acidic salt. Magnesium is actually not enlisted here as the cation of strong base. Okay, but sulfate, SO4, is considered an anion of strong acid. Therefore, this one is an acidic salt. Now, why is this considered an acidic salt? Again, remember that ions can only react with water if they are stronger acids or bases than water. In this case, the anion of strong acid cannot react with water, but the cation of weak base can react with water because this one is considered much stronger than the water molecule. So, when this one reacts with water, remember that cations are positively charged, and as positively charged ions, a positively charged ion, it will always react to negatively charged ion. Between these two components of water molecule, which one is negatively charged? That's hydroxide ion. And so, when this cation reacts to negatively charged hydroxide ion of water molecule will liberate, or it will give off, positively charged hydrogen. This will actually raise the pH, this will actually lower down the pH or increase the hydrogen ion concentration in water molecule, therefore making the solution acidic. Okay, so again, the cation here can now react with water molecule because this one is much stronger than water. So once this one reacts to negatively charged hydroxide ion, that's the time the water molecule will liberate or will give off positively charged hydrogen, which will make the solution acidic. Okay, how about for the alkaline salt? For the alkaline salt is made of cation of strong base and anion of weak acid. Okay, so some examples include sodium bicarbonate or baking soda and calcium fluoride, the major component of toothpaste. Okay, now as we have noticed here, sodium bicarbonate is made of sodium and bicarbonate ion. Sodium is actually one of the cation of strong base, and bicarbonate is an ion of weak acid. So these are the anions of strong acid, and as we have noticed here, there is no HCO3 or bicarbonate that is actually enlisted here. Therefore, bicarbonate is considered an anion of weak acid. Now, because the cation of strong acid cannot react with the cation of strong base the cation of strong base is considered much weaker than water molecule, then this one, cation of strong base, cannot react with water molecule. But this one, the anion of weak acid, is considered stronger than the water molecule, and therefore this one can freely react with water molecule. Now take note that anions are negatively charged, therefore between these two components of water, positively charged hydrogen and negatively charged hydroxide ion, which one will react to the anion of this weak acid here? an ion is negatively charged. So therefore, it will react to positively charged hydrogen. Now, once it reacts to positively charged hydrogen, water molecule will now liberate hydroxide ion. And since hydroxide ion dictates the basicity or alkalinity of a solution, then it will turn the solution alkaline or basic. Okay, so again, it turned the solution alkaline or basic because the water molecule now gave off negatively charged hydroxide ion. Again, the higher the hydroxide ion, the more basic the solution will be. Okay? Ano nangyari kay hydrogen ion? Nakipag-react kay an ion of weak acid. So, another example of alkaline salt is calcium fluoride. Calcium is actually one of the cation of strong base, but fluorine is not enlisted here as an ion of strong acid. Therefore, fluorine is actually an anion of weak acid. Now, what if, for example, a salt consists of a cation of a weak base and an ion of a weak acid? How do we classify that? Now, if the salt consists of cation and an ion of both weak acids and base, the classification will depend on the K or dissociation constant of the cation and an ion. Now, this K or dissociation constant here, we are going to discuss this next meeting. But the idea here is higher K or higher dissociation constant will determine the type of salt. Okay? So for example, we have here ammonium cyanide. Ammonium cyanide is actually a salt and it consists of ammonium ion as its cation and cyanide ion as its anion. Okay? Now, here, ammonium is actually a cation of a weak base. Why? Because, okay, these are again the cations of strong bases, and as we have noticed here, there is no NH4 enlisted here or ammonium ion enlisted here, so therefore this one is a cation of a weak base. Cyanide, on the other hand, is an anion of weak acid. Okay, so these are anions of strong acids, and as we have noticed here, there is no CN or there is no cyanide ion enlisted here. Therefore, cyanide is considered an anion of weak acid. Now, if we are going to look on the internet or to look on the dissociation constant of ammonium ion and cyanide ion on internet, the dissociation constant of ammonium ion is 5.7 times 10 raised to negative 10. And the dissociation constant for the cyanide ion is 1.6 times 10 raised to negative 5. Now, between these two, which one is higher? The one that is actually higher is the dissociation constant for cyanide, and therefore, cyanide will be the one that will determine the type of salt that we have here. Now, just a clarification, both ammonium ion and cyanide ion can react with water molecules since ammonium ion and cyanide ion are considered stronger than water molecule. However, because cyanide ion has higher dissociation constant than the ammonium ion, then cyanide ion will be the one that will primarily react with water molecule. Now take note that cyanide ion is an anion, which means that cyanide is negatively charged, and as negatively charged ion, it is always attracted to positively charged ion. Between these two components of water, which one is positively charged? So that is hydrogen ion, and therefore this hydrogen ion will react with the cyanide ion. Okay, and after its reaction to cyanide ion, this water molecule will now liberate hydroxide ion. Now again, the higher the hydroxide ion, the more basic the solution will be, and because of that, okay, this ammonium cyanide will create a basic or alkaline solution, okay, because of the liberation or the release of hydroxide ion. Okay, ano nangyari kay hydrogen ion? Nakipag-react kay cyanide. So those are the things that you need to learn in classification of salts. Thank you for listening and good day.